Okay, difference of two squares, part 2. Now it's a little known fact that 1 is a perfect square. 1 squared is equal to 1. And there are some common squares that really you should try to remember. These two crop up quite a lot: 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. Now it's important to know that powers, even powers, are squares. Let me just give you these as examples. X to the power 4. X to the power 4 is x squared squared. X to the power 6 is x cubed squared. And x to the power 8, you guessed it, x to the power 4 squared to the power 2. Let me just give you a little example to show you this. If we have 1, which remember is 1 squared, minus x to the power 6, or x to the power 6, as we've just written, is x to the power 3 squared. Writing that again in that notation, 1 squared minus x to the power 3 squared, we can use our difference of two squares. So that's x, that's 1 minus x to the power 3, multiplied by 1 plus x to the power 3. So that's it, perfectly factorized. There's some factorizations which come up quite a lot in maths exams. There are 3 basic types. The first type, which this is a typical example, 4x squared minus 9y squared. Okay, well 4, remember, is 2 squared, and 9 is 3 squared, so that's 2x squared minus 3y all squared. If we put the difference of two squares, 2x minus 3y multiplied by 2x plus 3y. So there we have it, perfectly factorized. The second type, we have 16 minus x to the power 6. 16 is 4 squared, x to the power 6 is x cubed squared. Using our difference of two squares, 4 minus x cubed multiplied by 4 plus x cubed. And our final example, (5x squared minus 20 y squared). Now we factorize by taking the 5 out, leaving this with 5 brackets x squared minus 4y squared, close bracket. And then we just carry on as before. The only difference with it is there is an extra factor outside the bracket. Now we have x squared minus 4y squared, but the 4y squared is 2y